Let me see if anyone has any explanation. A is address to 0th element. Correct. Masood, right? Okay. That's very right, Masood dear. That's very right. Just recall, as we said, that the array name, whatever array you declare, like here we are declaring an integer array of size 5. That is how we read this line of code. Integer array with the name A of size 5. That means it will be storing 5 integer elements. Fine. And that array name itself acts like a pointer, acts like a pointer pointing to the first element of the array. Fine. That is same as saying that A will be simply A is a pointer that is pointing to the first element of array. That means A is storing the base address to this array. Fine. It is storing the base address to this array. That's simple. Fine. Base address means the very first starting address to all those continuous integer variables. Fine. So it is okay if we write it as A plus I. Just go to the pointer arithmetic which we have covered. If we write it this way, when the value of I is 0, then A plus 0 in pointer arithmetic, you're just not adding anything. So that means simply the address of this very first element, here. Fine. So you're just passing that address. Fine. And the same thing if we write in here, like address of A0. Whenever you put square parenthesis, and in square parenthesis specify an index value, that would be like the 0th element. 0th is actually at 0th index. That is like the first element. This with A of 0, we are talking about this element. And if we put on an address before this, so we are talking about this base address of this element. Right? Right? So if we write it this way or we write it this way, both are correct. Fine. Similarly, this I will give you one more example. If when the value of I is 1, and if in any pointer you write A plus 1, what that will do? And just it's a repeat of the previous lecture. Just recall what this will do is this is just as work as an incrementer, right? What it will do is it will fetch the value at A. That means the address stored at A, plus add what value to it? Add value to it is size of integer, because it's an integer type array, size of integer into whatever constant you are adding to it. In this case, it is 1. So it will be, suppose again we are assuming the base address is 200. So in that case, it would be 200 plus size of int would be 2 bytes. So it will return 2 into 1. So it will pass 202. Address 202 precisely, right? Once we are writing A plus 1, that means we are talking about address, memory address 202. Correct? And let's go here. If we do pass it like address of A1, right? Why 1? Because now the value of I, the index variable, is 1. When you're talking about address of A1, that means at index value 1 you are talking about here. Fine. This was element A0. Now we all know that first element. This second element we access as A1, that is at index value 1, so on and so forth. Fine. If the address for this element was 200, so 200 and 201, at these 2 bytes, this integer value will be stored, which we access as A0, 0th index value for array A. Similarly, this will be 202 and 203, 2 bytes address for this second element of array, which is at index value 1. This is clear to everyone? So once we write this A1, that means we are talking about this 2 bytes of storage space, value at this 2 bytes of storage space. Fine. And if we fetch like address of A1, so we want the address of these 2 bytes. And as we discussed, it will pass you the base address. So the base address is 202. Fine. The same thing, it will pass 202. That means at 202 address, put that value. Same thing if you write this way, it will also pass address 202. We all good with this? So we are clear how it is. Same as writing this thing or writing this thing. They both will work in the same way. The logic behind this thing is the same thing, that the name of array itself acts as a pointer pointing to the base address of the array. Fine. So you can treat name of array just like a pointer pointing to the base address of array. Two ways you can use the name of array. Simple. Fine. We discussed two-dimensional array. We discussed how we initialize it. We discussed how we display the values, how this indexing of loop works. Fine. We also discussed taking values and printing values. You must have covered these two things. And then we discussed the pointer to an array, which is very, very significant, right? And we discussed that we basically create a pointer, and after that, we basically create a pointer, and using any three of these syntax, we make that pointer point to the array, fine, or the base address of array, precisely, right? Correct? And then as we were playing with the pointer, we can add some, we can increment a pointer, we can decrement a pointer, we can add some particular value to a pointer, and so on. So arithmetics of pointer we discussed. Using that pointer arithmetics and the play with pointers, you can access the elements in the array with a pointer value. You can change the elements of array using the pointer to an array. You can also access complete array using pointer to an array. Fine. So that is simply we discussed. Say this was a simple syntax telling you that if your pointer is pointing to this array and we want to, at index value 1, we want to put the value 5, that is how you will put it using pointer. Using only the array name, you could do it using this syntax. Correct? Similarly, using this pointer at index value 2, if we want the same value 5 to be there, using pointer, this syntax we will do it. And using array at index 2, we want to put value 6, then we can do it this way. Or we can put it here to be 6. Fine. So both are correct. Both are doing the same thing. This we are doing using array itself, the array name itself, accessing array element and assigning a value to it. This we are doing using a pointer to an array. Simple. Do anyone have any query at this syntax or at this syntax? Any query at these two syntax? Anyone? Anyone? Do we have any query, dear? Not yet. Okay. I hope this is clear to everyone. Fine. Okay. Now let's go to this syntax. This would be doing the very same thing. Just see, if you do like declare an array, first thing, declare a pointer of same data type as of the array. Then third thing, assign the base address of array to that pointer using any of these three syntax. Fine. Logically, all three are doing the same thing. Fine. Another way is this thing. Second way to doing the same thing is this thing. First, you declare an array. Second, the same thing. First, remain the same part, declaring an array. Second is declaring an array and at the same time initializing it. Fine. Instead of like third line, you do it at the time of declaration of a pointer itself. So that is the syntax for it. Is that okay? So that's just merging of these two lines. So that is how it is. Correct? Same way, here instead of A, you may also write address of A. You may also write address of A at index value 0. All three syntax will be correct. Fine? We all good with this? Next, I gave you to practice this question in the last class. How many of you have tried logically how it would be working? Can anyone write me the output for this one? Can anyone voluntarily would like to explain it and write the output? No? Anyone? Let me see if anyone comes up. Anyone? No? Okay. Let's quickly go to the explanation of this part. See, this is a very simple program we all understand. We are including the header file in the main function. We are declaring an array. Declaring an array is same as like creating a space of 10 bytes. Why 10 bytes? Because 5 integers space you are consuming. So 10 bytes. The very first one is A0, A index value 1, A index value 2, A index value 3. Do try to visualize this. This is very important that to understand how to visualize certain things. Fine. And the last element would be at index value 4. So we address that with A in square parenthesis index value 4. So we will be accessing this value. Fine. Make the difference. Once we are writing like array name and in square parenthesis any index value, say 2. That means we are talking about a value of this array at this index value. Fine. Fine. Okay. And if you write address of A index value at index value 2, that means you are talking about address in memory terms. Now we are going where you are storing this integer value, address of that integer value. That means at which byte address that value you are storing in memory. Fine. So that's the difference. Similarly, writing the same thing, you would be like A plus 2. If we write, then also we are talking about this address. Fine. And using pointer, if we want to write this, that we will be doing is dereference at address A plus 2. So these two syntax are talking about the same thing, and these two syntax are talking about the same thing. Are we all clear about it? That's important to understand. Fine. 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 Okay. Now we declared an array as well as we initialized it. Fine. And we understand it is optional to write this 5 here. You may eliminate it. We discussed this in the declaration initialization part. So it initializes every element 1, 2, 3, 4, 5. Correct? And suppose base address is 200. If it is 200, so like 200 and 201, at these 2 byte addresses, value 1 is stored. Then at 202 and 203, value 2 is stored. Then at 204 and 205, this value is stored. 206 and 207, this value is stored. And 208 and 209, the last 2 bytes, this last integer element is stored. Simple. Then you also created an integer I. Let's say at any random address 400 was created, and you haven't initialized any value here. So right now, up to this point of time, there is some garbage value in there. This after the execution of this line, this thing has happened in the memory. Right? Right? Next, printf arrays. So let me see, your output screen here. We have output screen. On this, arrays would be printed. Right? Arrays, semicolon will be printed. Then this line executed. Simple. Then we are executing a loop. In loop body, we have only one state, only one printf state. Fine. I think I'm back on this meeting. Yes. Okay. Sorry, dear all. Somehow, I don't know, I lost the internet connectivity. So I lost the connection to the meeting. I just find out I was not no more in the meeting. So let's start again. But could you tell me up to which point we were able to listen to me? Like, let me just give you a second. Just give me a second, actually. Let me fix things the way it was. It's okay. Where were we last? We were discussing the same. Okay. Let's come back. Let me present my screen again with you. Okay. I hope you people are not sleeping, right? Sure. Okay. I need to do something.
Yeah, ma'am.
Pakka? Good. Okay. See, this we were discussing. I don't know where I lost the connection in the previous meeting, at what point of time. But what we were just discussing is like we declared an array, so this happened in memory, and that's how the loop was going. So it will be printing output like arrays at a 0th index 1, at a first index value 2, so on and so forth, to all those values it will print. Up to this point I was discussing. After this I found out that I'm no more part of this meeting. Fine. So I think this is clear to everyone, right? This left side program, we already discussed it, right? That's how in memory 5 variables were created and index variable I was created, and using this loop how we were accessing all those elements. Correct? Fine. Okay. Just I want to add to your information as we discussed with the pointer to an array thing, so that you understand actually how things are going. Instead of this, you could also write, as we discussed, this same syntax, they will work in same way. We want to print the value of a plus I, right? Instead of this, if we write this syntax, even that is correct. It is just working on the logic that we are treating the array name as a pointer to an array. Simple. So this, just as we discussed, this syntax and this syntax are the same things. So we can, instead of this thing, we can use the same syntax likewise. I hope you are good with this, everyone. Fine. Okay. Now let's come to this program. This program talks about doing the same thing. Exactly, logically we are doing same thing. We are declaring an array, initializing its elements. We are declaring an index variable, and with some loop thing. Now, we're just printing all the elements of this array with precise information that index at index value 0 in this array, the value was 1, and so on and so forth. Right? The same thing now with this program we'll be doing with a pointer p. So let's go to this. This is simple header file. We are including this header file so that we can use our printf and scanf. Then in the main function, we are declaring an array, correct, and initializing a integer, declaring a integer variable I. So it will happen the same way as if we declare this one. So memory is created for 5 integer elements, that is 10 continuous bytes of space is allocated in memory, and the first 2 bytes we can access with value at first 2 bytes we can access with this a at index value 0, second at a at index value 1, so on and so forth. The base address again for this one is 200 and 201, so on and so forth. Fine, the same way, exactly same thing would happen. Here I was created at some random memory address, and it initially there was just a garbage value. Correct? Okay. Next thing happens is we are declaring a pointer and initializing it to a. So next what would happen with this is Again 2 bytes of space is created with a name P, which is a special type of special type of variable, which is pointer. Fine. And we are initializing it to the address of A. And the base address of A is 200. So it will store value 200. Correct? That simple will happen with this line of code. And suppose it also created in memory at some particular address. So that address, let's suppose we can take anything, let's take it 500. The address to this 2 bytes of space is 500. Right? Now, printf arrays, it will again print to you the very same thing, array is. Right? Then again, we are using a loop with our loop variable to be variable I, and in this loop body we again have only one printf statement, right? And as the loop works, it will work in the same way. Now first thing will happen is initializing the loop variable, that is I. So I will be initialized to value 0. Is that correct? Fine. Then we'll check I is less than 5. Yes, 0 is less than 5. So it will print this statement. Right? Okay, just one correction is here. Instead of 1, this is I. Please make this correction. Instead of 1, this is I. Fine. Now, when for I equal to 0, we are printing this statement. Then it will print A at index at %d, colon at %d. This way it will print, and will fetch this value for this %d from the first integer variable, first variable in this parameter list for this function. So whatever the value of I would be printed here. So initially it was 0, so it will print A0. It will print A0 equal colon. This % it will fetch from this value. And now precisely for value of I to be 0, it is P plus 0 dereference at that address. As P is a pointer, so it is storing an address, and that address is 200. Look here. So 200 plus 0, it will be 200 again. Fine. And at address 200, fetch the value at address 200. So it will go in the memory at address 200 and fetch the value at this. So it will print colon 1. Simple. So this first line is printed again. Right? Now, value of I will be incremented. So now I is, instead of 0, it is 1. Correct? Again, 1 is less than 5. Again, it will print this statement. Now it will print A %d, it will fetch the value of I, which is 1 now. Right? So A1 semicolon %d this time is P plus 1 dereference at that address. We understand this thing? Fine. So because P is a pointer, so we are dereferencing. Whenever we are dereferencing it, we are fetching the value at that address. Right? If it would have written only P plus 1, then it would have printed the address. Now it is this address. Right? And what this address is? P plus 1 is 202. Recall the same formula. That is value of P plus size of integer into 1. So 200 plus 2 into 1. So it is 202, as we just discussed. Right? So it is 202. If it would at address 202, dereferencing. So fetch the value at address 202, which is value 2. Simple. So now it will print this line, which is here. Again, increment the value of I, and so on and so forth. Fine. So it will have the very same print all the elements of the array, and the output will be exactly the way it was for the this program, first program. Correct? Correct? Are we all good with this? So what just the difference in the two is, this we were doing using simply the array variable name, array name itself, array index value. This we are doing using a pointer to an array. So using a pointer to an array, you can access the elements of array. You can put some value, you can change that value, and you can do anything. You just need to understand how this syntax is working, how you are initializing a pointer to an array, and how you are accessing with that pointer to an base address of array, how you are accessing various elements of the array. Right? Are we all good with this? Fine? 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 Okay. Now, all of you try a program. Write down. All of you try a program. Write down. Write a program. Write a program to create an integer array of size 5, to create and initialize. To create and initialize an array of integer of size 5, an integer array of size 5, fine, and print the sum of elements, and print the sum of elements, print the sum of elements, full stop. Do this all thing in the program using a pointer to an array. Do all this thing in the program using pointer to an array. Fine. I'm repeating my question. Write a program in which you will declare and initialize an integer array of size 5. Fine. Full stop. And you will print the sum of elements of that array. Fine. You will print sum of elements of that array. Simple. And you condition is, full stop, condition is you will do all this functionality performance using a pointer to an array. You need to stick to the logic that you will be doing all this thing using a pointer to an array. Fine. Everyone just quickly do it. Type it on a Word file, type it on a PPT file, wherever. And then you will be, randomly I'll be picking a roll number and you will be sharing the screen with us. Fine. You have just 2 minutes to do it. Go ahead. It's 23. At 25, you'll be explaining. Very good. Nikhil Gupta. That's right. You have, for the previous program, right answer. Answer is same as first one. Good. Right, Mahesh. Rajesh. Yes.